pretty extensive. Noah is a 2012 graduate of college. He received his BS degree in mechanical engineering. While he was here, he was an active member of the Society of Automotive Engineers and the SAE Baja Clinic project and competitions, which I was not a mechanical engineer, but obviously from what I've heard, that was always the go-to project and one that was well attended. Upon graduation, Noah received the TR Chandra Medallion Award from the Mechanical Engineering Department, and faculty and staff in the Mechie department cite that he was a strong student and an asset for the other students that needed support. So it sounded like Noah was already starting to show signs of what an engaged alumni would look like, even while he was still here. After graduation, he began his engineering career with the Gates Corporation, which is highlighted here. This was actually a position that was directly impacted from using Gates belts in the Baja car, where he worked to design and develop a new form of complex alternator decoupler for new vehicles currently in production. Hopefully some of you guys understand what that meant. It's lost on this ECE. In 2018, Noah obtained a master's degree from Oakland University, specializing in automotive engineering, where his thesis was based on the development of autonomous vehicles. After his time with Gates Corporation, Noah, is there anything else you're going to be able to say for yourself after
I don't know.
we read this bio?
So take it off.
Let me know if you just want to cut me off here. Noah obtained a position as a test and development engineer for automated driving with Continental. Recently, he was promoted to technical project lead for automated driving, where he leads a team of engineers developing autonomous vehicles and related technologies meant to advance Continental's vision for autonomous driving in North America. To date, his work has been instrumental in the development of 6 individual autonomous vehicles, the most recent of which is the Continental CUbE, a low-speed passenger transport vehicle aimed at full autonomous operation at college campus-like environments. Impressively, several of these vehicles featuring his work have driven thousands of miles autonomously. So with that all said, again, Noah, I'm sorry I stole your thunder here. We are grateful that Noah could be with us to accept his award. It was touch and go there. We thought he was going to be remote. We would do video, but obviously you're presently located in Michigan, so thank you so much for making the haul back to lovely Glasgow to join us. We really appreciate it. I, for one, think this is impressive, and it's something from the Alumni Council that we are looking to promote more of. We know not everyone is local and can not always come back to the campus, so we want to paint a picture here that even if you're remote, there's ways for you to get involved and stay engaged with your alma mater. So we look forward to those that will be traveling wherever you may be. Right, we still welcome with the open arms. So again, through all these words I lost. So each year we see Rowan's reach growing further and further, and Noah's impressive accomplishments are a superb illustration of that growth. So finally, with that, I would like to welcome the Henry M. Rowan College of Engineering Young Alumni Award recipient for this year, Noah Gedrimas.
So first off, it's really great to be back at Rowan. I haven't been back since I graduated, actually, and this place has changed a lot. Even this new building is really amazing, and I got a chance to walk around a little bit. You guys,
Let's bring it up a little higher.
Now the Mickey needs some ECE help.
All right. Good call. So I got a chance to walk around a little bit around the building and poke my head in some of the windows, see some of the projects going on. My time at Rowan was all about projects. I was always in the machine shop. Probably when I should have been at parties, I was working in the machine shop with Chuck on Saturday nights, and really had a great experience. As Anthony mentioned, I spent 4 years on the SAE Baja team. The last 2 years I was the captain of the team, and had some really good experiences there. And I'm so proud to be a Rowan alumni. I really believe it's something different. It's different than other universities. I've been out there, I've seen some, and I'm really proud of it. And so it makes me extremely grateful for this award. I really want to thank the committee for for acknowledging me as a distinguished alumni, so I really appreciate that. Secondly, I really want to congratulate the graduating class. Graduating from engineering schools is a huge achievement. Sometimes when you're in engineering school and all your friends are engineers, it's easy to kind of think, well, they all did it, but I think your freshman class was probably significantly bigger than your senior class, and that shows you the perseverance it takes to graduate from engineering school. It's really a big deal, and you guys should be very proud. It's a great work. I'll give you guys a little bit of a synopsis of some of the parts that, since I graduated, maybe that glazed over, but yeah. Right from the beginning, Rowan helped me get started in a career in automotive engineering. That's where I wanted to be. Specifically with the Baja project, I was able to work directly with Gates engineers that sponsored our team to develop that belt drive and get my initial start into the industry with them already knowing what my engineering capabilities were from working with them beforehand. That's a big advantage. That's what projects can do for you. And so that was really helpful in getting me started in automotive. I spent 2 years at Gates in research and development, working on some really cool projects. I learned a lot. About 1 year in, I figured out that maybe I don't want to design belts for the rest of my career. So I thought maybe I'll reach out, try something different. I identified autonomous vehicles as an up-and-coming field. It's kind of hard to miss. 4 years ago it was a little harder to miss, but it was something I identified I really want to do. But I was missing some of the criteria that are needed in a candidate to do that. I was a mechanical engineering degree. I knew a lot about engines. I knew a lot about transmissions. I didn't know anything about deep learning, sensorics, trajectory planning, any of those topics. So I went back to school. I kept learning. A couple years into my master's degree, I identified Continental. Continental had come and given a presentation showing off some of their autonomous technology. Continental's mainly known for their tires. Everybody knows us for tires. Continental's a huge automotive company though. Almost every part in the car we make to some extent. We've been developing vehicles for hundreds of years, or 100 years, and really we do a lot of good work. So I knew I wanted to be at Continental. It took me about 16 months to actually get an interview at Continental. I sent 15 emails to the hiring manager in the autonomous vehicle department explaining I really want to do this. And each email would be something new. I'd say, hey, I made a MATLAB script that did this, or I read this paper, I thought it was really interesting. And then finally the timing was kind of right. The hiring manager said, well, you know what, if he wants the job that bad, bring him in. Let's see what it is. So I did the interview, it went well, and I got hired as a test and development engineer. And I got to do some really amazing work with some really, really smart people. I'm going to show you guys a couple pictures of some of the work I did as a test and development engineer. I don't know, how can I change this slide, Sean? So this first project here, this is at the Consumer Electronics Show in January this year. So the Consumer Electronics Show is it's mainly known for televisions and toasters, Xboxes, but more and more so it's been automotive and specifically autonomous vehicle companies bringing their technology out and showing things off. So Continental, we sent some of our coolest technologies. This middle car was my vehicle, or what my team worked on. It was a valet parking vehicle. So what this would do is you could pull up to the entrance to a hotel or a restaurant, get out of the car, push a button on your cell phone, and the car navigates with nobody in the vehicle into the parking garage, finds an available parking space on any level, and parks. It avoids handicap spots. It doesn't require GPS because there's no GPS underground or in elevated parking structures with roofs. And it would avoid pedestrians. When you're finished with your dinner or you're ready to leave in the morning, you push a button on your phone, the car would come and pick you up. This is a big challenge anywhere. It was a big challenge on the test track. At the Consumer Electronics Show, it was all types of problems that the team didn't expect. The one thing, we had a Wi-Fi communication between the cell phone and the car. There was probably 10,000 other Wi-Fi connections from the Consumer Electronics Show next door from all of these companies showing off whatever they were showing off. So that was really cool. If you go to the next slide. Here. This was the core team that went out there to Las Vegas to set it up. It took us about 4 weeks total to finally get it working. We worked extremely late nights. We'd be there until midnight on on the roof trying to get this vehicle to work. And it just felt like one clinic project. It reminded me of my time at Rowan and how much it equipped me for it, too. I mean, really to know if we don't fix it, no one else will, and to just keep fighting for it. So that was a great experience. And we're always doing stuff like this. I want to show you my latest project, too. It's the Continental CUbE. This is it here. It's on a trailer. There's a reason I'm showing it on a trailer here. This is something that would drive around a college campus like Rowan here. It wouldn't surprise me if Rowan one day had an autonomous vehicle. They're such a forward-thinking company. Forward-thinking university. The reason it's on a trailer is our development center is in Detroit, or near Detroit. And our test track is in the Upper Peninsula of Michigan. It's about 300 miles north. So what we did was we would set up an integration where we would take 10 engineers, and then I would pull the vehicle up to our test track in the Upper Peninsula. We would have absolute focus, no distractions, to try to get the vehicle up and running, to get a feature working, get something working. And again, it just reminded me of my time on an EHawk project, which was my big clinic project. I don't know if it's still around, but electricity from high altitude wind with kites. We used to bring this kite project out to the beach or the peach fields or whatever here at Rowan, and it was complete focus. And this is exactly how my job is today. And yeah, I'm very grateful for this position. So recently, this year, I was, yeah, we'll show it in a second. Yeah, I'm gonna see it first. So this project here is called Cruising Chauffeur. This is what I spent most of my time on at Continental. This is a highway automation vehicle. So you could get in this car, merge onto 94, and take your hands off the wheel, and it would drive you all the way to Florida. You wouldn't have to pay attention. You could read a book. You could eat. You could do what you needed to do. Of course, it's not going to work, but this was a big project. So while I was trying to figure out that, recently, at the beginning of this year, I was promoted to the technical project lead for automated driving in North America. So, yeah, go ahead. Kind of cool.
Does that later out? You see how it's showing up and then we start and then confirm it.
Change ahead. Predicted highway change. Course of Chevron ending. Prepare to take over. Take over now. Stop on shoulder. Please switch off automated driving system to continue manual driving.
Yeah, so what you saw there was that's the driver handover, where you give control back to the driver to use the vehicle. But of course, what happens if the driver doesn't come back? If they don't respond, we're showing that the car would pull over into a shoulder on the side of the road. So that's really the key to that level 4 autonomy. Just want to show that briefly. But in January this year, I was promoted to technical project lead for automated driving in Continental in North America. So I lead a team of over 20 engineers in North America to technically get these vehicles working on all of these different projects. And all of these projects still exist to some extent. And I worked with some really exceptional engineers from many very advanced universities, from MIT, from Stanford, from Georgia Tech. And I'm not the most technically knowledgeable. I don't know the most, and so I really was thinking about, what is it about me that made me a good candidate for this position, to be able to lead this team. And the more I thought about it, I realized, for the same reason that I'm a Rowan graduate, it's that we know how to make things work in the real world. We know how to take a project that maybe looks good on paper, put it into a real world vehicle, and design something that we can test, we can debug, we can make it better, and we know how to to make it work in the real world. Rowan did a great job with that when I was a student here, and the projects were all about results. It wasn't about who could write the best SolidWorks model or who could do the best MATLAB simulation notes. It was when you actually built the thing, what happened. And this is the same thing that industry needs. Industry needs results. So that was really, really paramount to, I think, my success at Continental was the time I spent at Rowan. So I have a little bit of parting advice for the graduating seniors. First, you always keep learning. You have to keep learning. I think that an engineering degree, it doesn't mean that you know everything or everything about engineering, but it does mean that you can learn anything. If you made it through engineering school, you're a damn good learner. That's what that means. And I'm sure you had great professors that taught you really well, but I'm sure you have to learn some things on your own. This is your marketable skill. So when you go to, when you're in your interviews, explain, I can learn. This is evidence I can learn. Here was a problem I had, this is how I solved it, and this is what I learned from it. That's what we look for in candidates. And secondly, don't make excuses. Excuses are for losers. That was something my high school teacher taught me, and I've been living by it ever since. Excuses get in the way. They don't help. Sometimes they might even be valid, but it doesn't change the fact that they just get in the way. And lastly, stay in touch with Rowan, specifically your professors. I think we owe our professors so much, and it doesn't take much to share our successes with the Rowan faculty. So if you apply something that you learned in class at your career or in life in some way, and it helps you, shoot your professor an email and say, hey, I pulled out my notes and this heat transfer equation, I applied it to this light bulb problem, and this is what happened, and thank you so much. And that feedback helps so much, and it helps stay in touch with the professors, and that's really, really important. And lastly, you can look to your alumni for other people to work with. So I'm always looking for colleagues to work with at Continental. We've hired 2 other people from Rowan that I've referred into Continental. If you want to work in the automotive field in Michigan, or you want to work at Continental, or you want to work on autonomous vehicles at Continental, come talk to me, and yeah, we can do it. But I thank you for letting me talk, and yeah, congratulations again.
You can take your flag, and we'll take a picture in a second.
This building didn't exist when I graduated.
Well, I gotta say,